Okay, good morning, grade 9s. I hope you're well. I hope you're good. Sorry for the delay. We are once again entering into another segment of our lessons, grade 9, GEC Maths paper 1 and 2, 2022, the past paper of 2022. And today, what are we going to look at? We are going to continue with this paper answering from question 46. We had initially started from question 1, all right, and the playlist for this thing is actually on my YouTube channel. The link to my YouTube channel is in my bio. Guys, I think the quickest way to actually go to my YouTube channel is to actually go to my link, to the link in the bio. Or if you want to join any of the channels that are there, there's the WhatsApp channel, there's the YouTube channel. If you want to join any of those, you just have to go to the link in the bio and you have to copy and paste the link and put it on your Google search engine. Then you press search. It should lead you to the YouTube channel and to the WhatsApp channel, and then you can join in that way, because seemingly when you click on the link, it's very hard to join that way. Okay, so guys, today we are going to look at, thank you Angel, immediately, right? In the mornings I do grade 9s all the time, right? And grade 9s are an important group, so I do grade 9s. So we're looking at question 46 there on your screen, and the question is, what is the value of x? I want to bring the diagram a bit closer, so hopefully you guys can see it. They are asking us there, what is the value of x? So what you should then notice or realize is that that x that you have there, okay, there's a x plus 5 degrees, which is in the diagram. Okay, there is a 35 degrees that is in the diagram. There is also a 90 degrees, which is symbolized by the box. Okay, so these are the aspects that we have in the diagram. So if you look at those aspects that we have in the diagram, right, we can, right, use the line AD, which is a straight line, and basically find the angle or the value of x, right? So I'm just going to try and draw this diagram onto my paper, and then for a moment I'm just going to remove this so that you guys can then better see what I mean. Here we have, guys, do you see this? So we have this box, which means 90 degrees. We have x plus 5 degrees and we have 35. Now we know that from here to there is 90 degrees. From there to here is x plus 5 degrees, and from there to here is 35 degrees. When these angles that are next to each other, meaning they are adjacent to each other, when they complete, okay, they complete the straight line AD, then we say that these three angles, they add up to 180 degrees. Okay, so that's one way of viewing this particular diagram and then answering the question as to what x is. So we can therefore say x plus 5 degrees plus 35 degrees. So we take the 35, we add it to x plus 5 because these are adjacent to each other. And then we also add it to 90 degrees indicated by this box. This box means right angle. Okay, right angle. Okay, I think they wrote O here, which is that point is O. So x plus 5 degrees was 35 plus 90. We can say it's equal to 180 degrees. And what is the reason for that, guys? The reason is angles on a straight line. Angles on a straight line. Then from there, we are going to do what? Solve for x. We take the x we isolated on the left-hand side. Then we transpose. So in other words, 5, 35, and 90 are separate terms from x. We take them over to the right-hand side. And when we do, guys, the 90 becomes negative 90, the 35 becomes negative 35 degrees, and the 5 becomes negative 5. Then we can subtract those angles. 180 minus 90 is 90, 90 minus 5 is 85, and then 85 minus 35. And that will give us a beautiful answer of 50 degrees. So there we have it. X is equal to 50 degrees based on what we have calculated. All right. And it seems like we have not made an error. Alternatively, someone else could see things a bit differently. Someone else would see that since this is 90 and this is a straight line, they would see that the two angles that we have here, since this lies on a straight line, this means that angle BOD is equal to 90 degrees. Why we say those are? It's because BO is perpendicular to what? To AD. Then from there we can basically say x plus 5 degrees plus 35 degrees is equal to 90 degrees, and the reason is complementary angles. This is an alternative way of working out the very same angle. We can say, since this here is 90 degrees, grade 9s, we can say x, this angle, plus 35 degrees is equal to 90 degrees. And what is our reason? We say comp angles, meaning complementary angles. What are complementary angles? Complementary angles are angles that add up to 90 degrees. Then we can say x is equal to 90 minus 35 degrees minus 5 degrees, and then we can solve for x from there. So 90 minus 35, that basically gives us 55 degrees, and then 55 minus 5, that basically gives us 50 degrees. So these are two different ways of working out the same variable x. Okay, so this first approach, we used the fact that 90, x plus 5, and 35 degrees are angles that are adjacent to each other. They share the same vertex. All right, the point where this angle is formed, the same point, this angle is formed next to this one, and at the same point this angle is formed. So this is a common vertex, and when angles share a common vertex and they are adjacent to each other, we say that these angles, if they share a common vertex and they lie on a straight line, these are angles that are on a straight line and they add up to 180, as long as the angles complete the straight line, which is why we say x plus 5 plus 35 plus 90 degrees is equal to 180, and we say angles on a straight line. Then we can solve for x, take the angles over, we get x is 50 degrees. Or if we don't use that method, we could use this one, where we can see, if this is 90 as the box suggests, then it means that this angle BOD, this entire angle, is also 90 degrees. Why? Because BO is perpendicular to AD. Then we can say x plus 5 plus 35 is equal to 90 degrees, complementary angles, and then we can solve for x from there. Okay, so going back to this guy. Going back. So what is the value of x? Is it A, 85 degrees, B, 55 degrees, C, 30 degrees, or D, is it 50? Guys, we just worked it out. The value of x is actually D, 50 degrees. And we had just calculated it using two different methods as grade 9 learners. So grade 9s, I hope you are clear here You know, that's how you would answer a geometry question as a grade 9 learner, where you are required to basically solve for x in that diagram. Number 46. Now the individual that said, "Sir, please do Pythagoras next." Let me see you say that comment again, and maybe send a rose or something so that I can actually be someone who is eager to do that I can do that for you. But remember, I'm just answering this question paper. If I want to deviate from this, then I need to see something significant happening in, number 47. I think people that do that, they have, I can actually deviate from my plan, but if not, guys, I'm not going to deviate from my plan. I'm sticking to the questions that I am supposed to answer, unless, of course, you can show me that, okay, it's worth the deviation. Let's look at number 47. Which statement best describes an isosceles triangle? Guys, A, is it one angle is 90 degrees? Does an isosceles triangle have one angle which is 90? B, one angle is greater than 90. Is that a property that an isosceles triangle, one angle is greater than 90? Is that what the best statement which describes an isosceles triangle? C, two sides and two angles are equal. Is that the statement that best describes an isosceles triangle? Two sides and two angles are equal. Or D, two angles opposite equal sides are equal. Is it A, B, C, D? Buhle says D. Buhle says D. Two angles opposite equal sides are equal. What does everybody else say? So it's only Buhle who is actually really in this live and is actually answering. KO says C, two sides and two angles are equal. Okay, let's look at the options that you guys have said. Let's say we were to go with KO's statement. The statement says two sides and two angles are equal. Let's say we had triangle ABC. If we are saying two sides and two angles are equal, these are two angles, we can say those are equal. And let's say these are the two sides, those are equal. Okay, I didn't specify, I just said two sides and two angles are equal. So if these two angles are the ones that are equal, and then it's these two sides that are equal, does this qualify as an isosceles triangle? Guys, no. Not even. Two sides and two angles. It did not specify which. It just said two sides and two angles. Is that an isosceles triangle? Not even. Can't be. This cannot be an isosceles triangle. Okay? Because remember, as the letter D says, so C is out. The letter D says two angles, okay, which are what? They are opposite. So this angle is opposite. These two angles opposite equal sides. This angle is opposite this side, and this angle is opposite this side, and these two sides are equal. So it is D, definitely, not C. D is the best statement which best describes what an isosceles triangle is. So be very careful, guys. Okay, there is that theorem statement that says angles, and usually when we use it, we write it this way: angles opposite equal sides. So when they say there D, two angles opposite equal sides are equal, that's the one that best describes a what? An isosceles triangle. Okay, in actual fact, we use this a lot. All right, we use this a lot. Let's say I give you 30 degrees triangle ABC, and then I ask you, what is the angle C? Okay, to find angle C, you would say angle C is also equal to 30 degrees, and then when you write your reason, you say angles opposite equal sides. This is basically the reason that we usually utilize when using the idea that you have two sides and these angles are equal. We don't write that reason base angles of an isosceles triangle are equal. Okay, I understand that. Yes, you mean that these two angles are actually equal, right? Because of the sides that they are opposite, which are also equal. But please, the reason base angles, if ever you say angle C is equal to 30 degrees and you write base angles of an isosceles triangle, okay, I understand that you are basically trying to tell me that those two angles are equal because of that, but we don't use this reason. This is a reason that we don't use anymore. All right, so we don't use this reason, but this one is the one that is in the acceptable reason document that we use. So we would say C is equal to 30 degrees and we say angles opposite equal sides. Let us familiarize ourselves with this reason so that even when we go to grade 10, when we do these things, we do them in accordance to what has been stipulated or given to us as per the document that is the acceptable reason document found in the exam guideline. So that one is the one. So all in all, our option for number 47 is D. Okay, I understand if Buhlebendalo, that was given by your maths teacher. Let me just encourage you. All right, when I used to teach maths earlier on, at the beginning of the profession, when I started teaching maths, I used to use that reason. Do you know why? That was the reason that I was taught when I was at school. Then all of a sudden, when I came and became a teacher, I soon realized that certain things basically had been updated so that they can actually be a better representation of what theorems actually mean. So when I say to you, update your understanding to angles opposite equal sides, do you see even in this number 47 they said D is the best option? Two angles opposite equal sides are equal, so that one is appropriate. So for geometry purposes, whenever we are given a triangle and we conclude that angle C is 30 degrees based on the sides, we have to say angles opposite equal sides. So please, not in any arrogance do you go now to your teacher and say, "Sir, I learned from another sir that this is the actual reason." Please don't be arrogant. Okay, hopefully some way, maybe you can go to your teacher and just go to them and say, "Sir, in all humility, you just go to your sir and say, sir, I came across something like this, and I was learning something from someone, and they spoke about a document called the acceptable reason document found on the exam guideline, and they indicated that in that document they speak about theorems that relate to triangles, and in those theorems that relate to triangle, the document itself, which is a document that apparently you guys use for teaching, there is the statement there that says the angles of if you have an isosceles triangle and you have two angles and sides are equal, and you want to indicate that the angle is equal to the other, we use angles opposite equal sides. And apparently this reason is there in that document. Is that the reason I should use? You don't even come and say, "Sir, that's the reason." Is that the reason that I should use, sir? And can you check it out for me? Because I want to be sure, especially since I'm going to grade 10 next year and I want to do pure maths. That's how you go about it, okay? How you go about it is very important. So just something to note there. Let's move on. I hope you guys are learning something from this, because that's important to me. Okay, let's move on to number 48. Number 48, there is the diagram, right? I'm sure you guys can see it very well. The diagram is very clear. We are told that AB is parallel to what? To CD. And the minute they say that, guys, I'm sure a lot of warning bells, they actually ring for all of you, as they should. The minute they say parallel, guys, we should have some things just go off in our system. The three relationships that exist between what? Between parallel lines. That's very important. Secondly, they are then saying to us that GMH, triangle GMH, is an equilateral triangle. Once again, if they say equilateral triangle, some certain things need to go off in your system. Then they are saying, what is the value of who? Of y. The value of who? The value of y. Is it A, 25 degrees? B, is it 20 degrees? C, is it 60 degrees? D, is it 35 degrees? So what I'm going to do is I'm actually going to remove so that we can actually deal with what we have before us. So we want the value of y. This is a AB and CD, those are parallel lines. AG, there's the 4y plus 20 degrees there. So if we can find the value of y, that would be great. But currently, we have no other information, here. This triangle, we are told, is what? Is an equilateral triangle. If it is equilateral, then there's something that we need to actually indicate about an equilateral triangle. Guys, we know that these angles are all going to be what? They're all going to be 60 degrees. So this is what I'm going to say. Angle H1 is equal to angle GMD, which is equal to angle MGH. Now I'm very specific in doing this. Right? Angle H1, which is that, is equal to angle GMD. This angle is equal to angle MGH, that angle. You see the middle letter indicates the angle I'm referring to. Okay, I could say H1 here because in the diagram itself, I have been provided with 1 here. So this is angle H1. This is not the value of the angle. No, it is the indication that this angle is H1. So this is angle H1. But here, there's no 1 or 2 or 3. So I can't write 1, 2, and 3. I have to actually use my sides of the triangle to indicate the angle I'm referring to. So it's angle MGH, or I could say angle HGM. Okay, so these 3 angles are equal to what? They are all equal to 60 degrees. Why? Now in that document, the acceptable reason document, there is no clear sorry about that. There's no clear reasoning. So I'm just going to write equilateral triangle. Now guys, check this out. If that H1 is 60, then it means EGA is also 60. So angle H1 is equal to angle EGA. Because I can see these lines are parallel on top of this parallel line on the same side of the transversal line. If this H1 is 60, then it serves to reason that this angle AGE or EGA is also what? 60 degrees. That is my F shape, guys. Parallel lines, the top and top angle, those are corresponding angles. Then remember, when I write corresponding angles, I indicate the lines that are parallel. AB is parallel to CD. AB is parallel to CD. So if that is 60, I use my pencil, I update my angle. That is also 60. I use my pencil, I update that angle. Then you should see that this 60 and this 4y plus 20 are lying on a straight line. And they are sharing the same vertex, vertex G. So I can say 60, this angle, plus 4y plus 20, they complete the straight line. These two angles, what can we say about them? When we add them together, 60 plus 4y plus 20 should give us what? 180. So we can say 60 plus 4y plus 20 degrees is equal to what? 180. These two angles can be added together and they should give me 180. What's the reason? Angles on a straight line. That is why. Now I am free to solve for y. So I can say now 60 degrees plus this bracket 4y plus 20. Remember, this is one term. I distribute the plus sign. I have 4y plus 20 because positive times a positive is positive. Positive times another positive is positive, equal to 180. Now I isolate the term with y, which is 4y. I transpose. Take what? 20 degrees over becomes negative 20. Take 60 over becomes negative 60. So now I know this is 4y is equal to what's 180 minus 20 minus 60? 180 minus 20 minus 60. Guys, in the event that you miss this live lesson or you are rushing, you are going to school and all of that, please make it a point that you go to my link in my bio, both my links in my bio. You can first copy and paste the WhatsApp link. Go and paste it, copy the link, go and paste it on your Google search engine, then press search, and then it should lead you to my WhatsApp channel. Join the WhatsApp channel, be part of it. You can scroll up and down, you can look at all the papers that I have uploaded on that WhatsApp channel together with the links to previous or past videos that I have actually posted. Even this one, when I'm finished with this particular live, I upload it onto the YouTube channel. I upload it to the playlist. There's a playlist there that's called GEC 2022 Maths. It's there, guys. It has all the first 7 videos that I've done, or from question 1. Now we are on another question, okay? And you can actually see how I've step by step shown you how to do these particular questions. You can go to the link in my bio, copy and paste the second link, which is the YouTube channel. Go and paste it on the Google search engine. Press search. It will lead you to the YouTube channel. Subscribe, and then make sure that you watch the videos that I've done previously and get yourself equipped for the maths exams that are coming up. So 180 minus 20 minus 60. I thought someone would have typed, what's the answer? 180 minus 20 minus 60. That is 100. Then what do we do here? We divide both sides. The coefficient of y is 4. We divide both sides by what? By 4. We get an answer. 100 divided by 4 is 25 degrees. So there's the answer. Step by step. Step by step. You see? Okay. So it all started by me saying angle H1 is actually equal to 60. Angle H1 plus angle GM, this angle D, which means that angle is equal to angle MGH, which is that angle, which are all equal to 60. Why? Because equilateral triangle. We know that for an equilateral triangle, all sides are equal and all angles independently will be 60 degrees. Then, since we know H1 is 60 degrees, that means angle EGA is equal to angle H1. Why? Corresponding angles. That is our F shape. Our F shape says that when we have two parallel lines and there's an angle on top, an angle at the top, those angles on the same side of the transversal line are equal. So that means they are 60 degrees. The person who's saying too early for maths, what you could do is you could actually just send me gifts so that the earliness of the maths, you can show your appreciation that I'm serving you and your brothers and sisters by sending gifts there. There's a rose, there's an ice cream, just send the gift rather than say it's too early for maths. It's good time. The early bird will catch the distinction, you know. That's the very important thing here for maths. That's what we want, you know. A lot of learners have sent a lot of nice messages. Some of you on, in the inbox. Some of you join my live sessions. I don't know you, but you always are here. And some of you have shared messages about your term 3 results, and you are saying you are getting distinctions. I'm very happy for that. That means that these lessons are helping. Okay, so those people who come and comment these things too early for maths and all of that, understand that there are people who are actually gaining from the earliness of the maths. Okay, so please, let's be positive with our comments. Anyways, after finding that this angle H1 is equal to angle EGA, we must be specific. Angle EGA, we can say angle AGE. Okay, that's 60 degrees. Okay, that's very important. That is very important. Narcissistic, I'm busy explaining that. Okay, so let me start again. I said, okay, this 60 and the 60 were not initially in the diagram. Okay, so I said angle H1, this is angle H1, that's angle H1. That was there. Okay, that one was there to indicate this angle is angle H1. Then I said it's equal to angle GMD. So this middle letter indicates the angle I'm speaking about. So angle GMD, which is also equal to angle MGH. The middle letter, which is there, indicates the angle. I put the cap on there, that's the angle. So these three angles are all equal to what? 60 degrees. Why do I say that? It's because I was told that this triangle is an equilateral triangle. Triangle GMH is equilateral. This side is equal to that side is equal to that side. So we know that the angles are independently equal to what? 60 degrees. That's why I could say that they are equal to 60, because I know for an equilateral triangle, all sides are equal and the three angles are individually equal to 60. So I say equilateral triangle is my reason. Then, since I know angle H1 is 60, I can see there's a relationship between angle H1 and angle EGA. What is that relationship? It's corresponding. This angle, this is the line that's called the transversal line. On top of this parallel line, we have angle H1. On the same side of the transversal line, we have angle EGA, which is also on top of this other parallel line. So these angles, angle H1 and angle EGA, correspond. And we say since H1 is 60, then angle EGA is also 60 degrees. The reason, correspond angles. We don't forget, guys, when we are writing this reason, to also state the parallel lines. Failure to state the parallel lines leads to penalization of the reason mark. You must state the lines that are parallel. AB is parallel to CD. You must not just say corresponding angles, but you must also indicate that AB is parallel to CD, because it's because of the lines being parallel that these corresponding angles, we say they are what? They are equal. Now, you have 60 there. I update my diagram. Every time I get something, I update my diagram. That's 60. That angle, EGA, has a relationship with this angle, EGB, which is 4y plus 20 degrees. So I can now say this angle, which is 60, plus that angle, which is 4y plus 20 degrees, are what we call angles that are lying on a straight line, and they are adjacent, meaning they are next to each other. They share a common vertex. It's when they share a common vertex, which is vertex G, that we can say this angle plus that angle, they complete a straight line from here to here, and then from here back to the straight line. These are angles on a straight line. My protractor would move from here to here. That's 180. So we say 460 plus 4y plus 20 is 180. Reason, angles on a straight line. This is the acceptable reason from the acceptable reason document. Now we can solve for y. Take the 60 over. Take the 20 over after removing the bracket. Positive times a positive, positive times a positive, that's still positive. We move over the constant values. 20 becomes negative 20, 60 becomes negative 60. We add the values together, we get 100. We divide both sides by the coefficient of y, which is 4, and then we get y, which is equal to 25 degrees. So hopefully that helps clarify and explain to those who are asking what they were asking. Now let's go back to the diagram and check which is the option that we should choose. What is the value of y? Is it A, 25 degrees, B, 20 degrees, C 60 degrees, or D 35 degrees. Guys, straightforward this thing. It is A 25 degrees. Okay, Y 25 degrees. Zulu, Ayanda, instead of telling me that I've put you in school, you might just gift. Okay, guys, please, if you guys have no positive things to say, rather send me gifts, because you guys know that I'm doing something positive and good for your brothers and sisters, your nieces and nephews. Please, man, the least you can do. The least you can do. Okay, question 49. Now look at question 49. Just take a moment. That question, they are saying AC is parallel to DE. Hopefully you see AC and you see the fact that, oh, really indeed they are parallel. AC is parallel to DE. And secondly, angle F is 58 degrees. Angle F is 58 degrees. I'm giving you a chance to really look at this. Angle C is 86 degrees. As you read the statement, you go and look at your diagram and check, is it there? Is that information really there? Because that's very important. GE is 8 centimeters. Is really GE 8 centimeters? Yes, it's there. EF is 12. You go and check. Yes, 12 is there. FG is 4 centimeters. Is it really there? Yes, you can see it is. FG is 4. AC is 4 centimeters. AB is 6 centimeters. Is it really there? Yes, it is. And then lastly, BC is 2 centimeters. All of this information, okay, maybe some of the things that are there are just merely distractions. The one thing they want from us is, what is the size of angle E1? Where is E1? There is E1. Okay. They want us to start, know what the size of E1 is. So they have options there. A, is it 36? B, is it 58? C, is it 86? Or D, is it 22? Okay. So take some time. You can analyze it. You can even attempt it yourself and check. All right. So any thoughts, my dear beloved? We want angle E1. That is what we want. If we can get angle E1, we are good. We are sorted for days. Now GEC, if GEC was paper 2, this is a question, or at least this is a diagram that seems very complicated, but if you know your stuff, then you might find that it's not as complicated as you think. It's not as complicated as you think. So for instance, angle E1 has a relationship with angle A. If you think about lines that are parallel, do Do you see angle E1? Yeah. I'm not saying anything really, but look at angle E1 and look at angle A. They have a relationship, because if AC and DE are parallel, then angle E1 and angle A, they are what type of angles? Do we know, people? Can anyone tell me what sort of angles are angle A and E1? If the lines are parallel, DE is parallel to AC. So what relationship would we be speaking about as far as angle E1 and angle A are concerned? Lutomboya is saying, please do grade 10 Euclidean. Lutomboya, this here is a typical question that you would get even as a grade 10 learner doing Euclid. Okay? Because grade 9s do the foundations. And this here would be a question maybe that you could be asked, as well in grade 10. So the question is, you are a grade 10 learner. This is a grade 9 question. Can you answer me there? And could you lead me in going ahead and finding what is the size of angle E1? Okay, so like I said, guys, from what I can see, angle E1 is actually equal to angle A. All right, but I don't have the angle A. I don't have any numerical value there. I don't have a numerical value even for angle what? For angle E1. I don't. I absolutely don't. Okay. But I know that those are alternate angles. Okay, so if I had something, I would be able to move there. Look at something else there as well. If you guys look, okay, Nico, you're saying would B1 be 58 degrees? Question is why? Why are you saying B1 is 58? Because you can't just say B1 is 58 if you don't give me a reason. Remember, geometry needs reasons. So if you're saying B1 is 58, why? That's my question to you. I'm not saying it's not, and I'm not saying it is, but I just want a reason. Remember, you need to support what you are saying. Would B1 be 58 degrees? Under what reason? What condition? Why are you saying that? So, I'm awaiting your response. Why? Because opposite sides are equal and they add up to 180. Firstly, asavela, because opposite sides are equal. Which opposite sides are you talking about? Which opposite sides are you talking about? Which opposite sides? A and C. Okay, that does not make any sense to me at the moment. I'm finding it hard to understand. Firstly, asavela. Okay. Yeah, this one I'm not rushing into going and answering because I want you guys to also think. Okay, Lloyd. All right, I see Lloyd there. Dumisani. Is it Dumisani or is it Dunisani? Okay, so Lloyd is saying angle D. Okay, and specifically, because we need to be specific then, all right? So EDC is equal to 86 degrees. That's what Lloyd is saying. So that entire angle is 86 degrees. That's what Dunisan is saying. Angle EDC is 86 degrees. Angle EDC is 86 degrees. Why are we saying that? Alternate angles, of course. DE, AC is parallel to DE. So the entire angle there according to Lloyd, is 86 degrees. And I agree with him. EDC is equal to angle what? Angle ACB. So ACB is equal to angle EDC, or you could say CDE. Okay, so that entire angle is actually 86 degrees. That I can agree with. That I can definitely agree with. Can definitely agree with that one. Okay. Definitely. Now, guys, if you actually check something out before too many things happen, okay, when you are doing geometry, you can collect some true piece of information from the diagram. Okay, so I just wanted to indicate here all of these things that I would write down. Maybe they are not connected as of yet, but they are leading to something. All right. I usually say you can compile what I refer to as a grocery list, where you are writing down items. All right. So I just wanna. Okay. So for instance, like I said, guys, angle E1, right, is going to be equal to angle A, right? We know that. The reason is alternate angles D is parallel to AC, right? Yeah. Okay, so this is what I call a grocery list. Okay, I'm not answering any questions yet. I'm just sort of like looking at the information and I'm trying to get some reasonable things from it. I want you to turn your attention, guys, to two triangles here. And I want you to note something. Do you see triangle ABC and also triangle GEF? There's something very interesting about those two triangles. And let me just indicate what those interesting things are. Okay, from what I can see, look at EF, look at AB, look at AC, and look at EG. And then lastly, look at BC and look at GF. I am noticing something here, guys. Very, very interesting. This here, AC over GE. AC over GE. And look at this as well. AB over EF. Okay, and then lastly, look at BC over GF. Something very interesting. Look at AC over who? GE. Now AC over GE. AC is 4 centimeters. GE is 8 centimeters. AB is 6 centimeters. EF is 12. BC is 2 centimeters. And then lastly, GF is 4 centimeters. When you simplify all of this, what do you get, guys? 1 over 2, 1 over 2, 1 over 2. What in the world do we mean by triangle ABC and triangle GEF? If the sides, the corresponding sides, are in the same ratio or proportion, we can then conclude that triangle what? Now be very careful with the order. Very careful with the order. Very careful with the order, guys. Okay, it's no small matter. So here we are seeing that there are similar triangles. Let me tell you this. If we don't know similarity,
How in the world would we have been able to find or look or even see that these two triangles are similar? Triangle ABC and triangle EFG. But now AB, remember, we had AC over GE. So let's just say AC, and then for the other triangle, say GE. Now, guys, maybe it's EG or GE, but ACGE, AB and EF, AB and EF. So let's say EG, AB and EF, AB over EF, and then BC and GF. Guys, look at this. AC over EG or GE. Isn't that the two sides that are corresponding? I can then say similar. So AC over GE. Okay, the first two, the ratio is half. The AB and what? EF. That's how it should be. Then lastly, BC and what? GF. The last two. That is actually similar triangles. What do I say? The reason is what? Sides in proportion. Okay, sides in prop. Now guys, if the triangles are similar because of sides being in proportion, what do we then know about the angles? Guys, it simply then means angle A is equal to angle G. Therefore, angle A is equal to angle G. Also, angle C in those two triangles is equal to angle what? Angle G. And then angle B is equal to what? Angle F. That is the conclusion we make because the triangles are similar. The angle A is equal to angle E, angle C is equal to angle G, angle B is equal to angle F. Now let's go back. Angle C. Okay, Liam, you are asking how do you know which sides to divide by in the triangle? Now Liam, remember that for triangles that are similar, the sides are in the same proportion. I repeat, for triangles to be similar, the sides must be in the same proportion or in the same ratio. Ratio means fraction, okay? So I looked at the two triangles. That the reality is that because similarity, when I do geometry, is also something that I think of considering, that came to my mind that, okay, let us check with these many sides that we've been given. We've been given this side, 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 we've been given this side. And I was like, okay, so what is the role of being given this side? In my head, I was thinking, why have we been given these many sides? And then when I looked at 6 centimeters, I looked at 2 centimeters, I looked at 4 centimeters, I was like, oh, this is triangle ABC. Okay, that's fine. When I looked at 8 centimeters, I looked at 12 centimeters, I looked at 4 centimeters, that is triangle GEF. And then I asked myself, is there any relationship perhaps that exists between these two triangles? Then I began to look at the sides, AB. Then I looked at this one, I was like, okay, what's happening with AB? Does it relate to any of these sides? Look at AB, does it relate to GF? Okay, and I could see no. Okay, does it relate to GE? No. Does it relate to EF? Okay, maybe it does. But let's check other sides. BC. Hey, something is interesting here. AC, if I multiply this by 2, I get that. BC, if I multiply this by 2, I get that. AB, if I multiply this by 2, I get that. So that means that the sides of these triangles are in the same proportion. Now let us conjure up the relationship. if you get the same ratio for all, that would also be correct. Yes, yes. So now I then identify the two triangles, triangle ABC and triangle GEF. Then slowly but surely, having seen that relationship, then I need to then set up ratios in accordance, because if all the three corresponding sides are in the same ratio, then I can conclude that the triangle is similar. But I need to be careful when I write the order of the letters of my triangle, because it needs to agree with the ratio of the sides. So I know I said AC over GE, but maybe someone else would have said GE over AC and gotten 2 over 1. Someone else could have said EF over AB and gotten 2 over 1. Someone else could have said GF over BC and also gotten 2 over 1. That's also 100% correct. Had you done that, that would have been fine. But it's just that I decided to say AC, because AC relates to, because AC relates to EG. That's why I said AC over GE. I could have also said GE over AC, okay, and gotten 2 over 1 instead of 1 over 2. That's okay. But what do we see? That the relationship AB related to EF, I get 6 over 12, which is also half. BC, which is 2 over GF, that also gives me 1 over 2. Same ratio as the similarity suggests. If the sides are in the same ratio or proportion, then we know that the triangles are similar. So then I got the same ratio. And what I do understand is that AC should relate some way to GE. But I must make sure, guys, that the order of the letters agrees. So I write down AC. AC is in the same proportion as, yes, GE. But you remember, initially I wanted to write GE, but then I was like, let's write what instead? EG, because GE and EE are, GE and EG are the same thing. But what I want to do is to make sure that when I write AC and GE or EG, it does not put off the AB and the what? The EF relationship, right? And ultimately it does not put off the what? The B and C, which should relate itself back to G and F. Had F and G been written, or let me say if the order had been GE, then it would have compromised that. So I need to be careful when I write down my 3 letters of the triangles. You can see, guys, AC must relate to EG there. First 2 must relate. CB must relate to GF. Okay? And then AB must relate to EF. All 3 sides are in the same, the corresponding sides are in the same what? Proportion. And if the triangles are similar, then the angles angle A is equal to angle what? E. Sorry, guys. Angle A is equal to angle E. Sorry. Angle C is equal to angle G, and angle B is equal to angle F. That's a conclusion we make because the triangles, we have proven that the sides are in the same proportion, therefore the angles, okay, are equal, that are corresponding. Angle A is equal to angle E, angle C is equal to angle G, angle B is equal to angle F. So Liam, I hope that answers your question. Okay, please let me know in the comment section if you've been answered. If you get the same ratio for all, that would also be correct. Yes. Whether I care, you would have written as a G over AC, 2 over 1, 2 over 1, 2 over 1. With that would have also been fine. Okay. Now, since now we know that angle A is equal to angle E as well, angle A is equal to angle E. Now, specifically, which angle E are we talking about? We need to be specific here. So if we look at the triangle, this angle A is equal to which angle E? Angle E2. So let's specify that it's E2 that we're talking about. Okay. Angle C is equal to angle G. Which angle C? Angle C and angle who? Angle G. Which G? We're talking about EGF. All right, in that triangle. Then of course angle B who? B1 is equal to what? Angle B1 is equal to angle F. B1 is equal to F. So now we can say if angle B1 based on similarity is equal to angle F, we knew that angle F is 58 degrees. So that means what? That means this is 58 angle B1. Okay, but guys, we need to show that. We can't just say angle B1 is 58 degrees. Okay, I think someone had said that earlier on, but the thing is we need to indicate that through proofs. All right, working out must be shown. That's very important. All right, then if that is 58 degrees, angle C, right, this angle C is equal to what? It's equal to angle EGF. So angle C, so that means that is 86 degrees. Okay, so angle C, sorry, this was based on similar triangles. Okay, I just indicate angle C is equal to angle EFG, which is actually equal, what's EFG equal to? EFG. Hi man, what's EGF? What am I saying here? EGF. So angle C is 86, so that means that's also 86 degrees. Okay, that's on the basis of what? Similar triangles. So I'm updating my diagram as I go ahead. That's 86. Then lastly, E2. All right, remember I had initially, so E2 is actually equal to what? Angle E2 is actually equal to angle A. They are saying E2 is equal to angle A. Now, the sum of angles in a triangle should help me out with that. 86 plus 58, sum of angles in a triangle should help me out with that. So I'm going to say in triangle ABC, okay, 86 degrees plus 58 degrees plus angle A is equal to 180 degrees. And the reason, sum of angles in a triangle. Now you can write either sum of angles in triangle, or you could write interior angles of triangle, or you could write angle sum in triangle. These are the acceptable reasons that they accept in the exam. Sum of angles in triangle, or you could write interior angles, INT angles of triangle, or you could write angle sum in triangle. We solve for A, guys. In that triangle, 180. You see, it's important to say in triangle ABC, indicate the triangle, and then you solve for A. Because when you say in triangle ABC, you can loosely say this is angle A. But if you don't indicate in triangle ABC, then it's important to say angle BAC. You would have had to say that, okay? But because I've indicated the triangle, the person who's marking me is like, okay, I know the angle A that he's referring to. So 180 minus 86 minus 58. Please, guys, what is angle A? Calculator. Okay, thank you, Luto. 36. Then if you remember from my grocery list, okay, if you remember from my grocery list, we had said angle E1 is also equal to A. Okay, so angle E1 is actually also equal to A. And that means angle E1 is actually what? 36 degrees. And that was because alternate angles are equal. Alt angles, we state the lines that are parallel. AC is parallel to DE. What a long way to freedom, guys. What a long way to freedom. Remember, the question was, what is the size of angle E1? What is the size of angle E1? So ultimately, After having found it, A, which is 36 degrees, I found that angle E1 is 36 degrees. And that's the reason alt angles AC is parallel to DE. Okay. Long walk, guys, but worth it, right? Long walk, but absolutely worth it. I get my marks. And then, of course, I am able to select the right option. So similarity is very important as well. We need not forget the concept of similarity in our grade 9 syllabus. Move right along. Next question. We answered 49. The size of E1 is A, 36 degrees. We move on to 50. Okay. Remember Enrico Maritz, we were not looking for E2. E2 is also going to be what? It's also going to be 36 degrees because angle A was equal to angle A, if you remember very well, Mariko. Okay, I'm guessing you just wanted to also know that. Remember, according to the similarity of triangle, angle A was also equal to E2, according to the proof of the similarity of the triangles. As we had proved that the triangles are similar, we found that angle A is equal to E2. But remember, because of parallel lines, we also know angle A is not just only equal to E2 because of the similar triangles, but angle A is also equal to angle E1 because of these are parallel lines. Those two angles are alternate, the Z shape. And these are lines that are parallel. So that's why we say angle E1 is equal to A, which is equal to 36 degrees. Alternate angles, AC is parallel to DE. Okay, so we're not really bothered about finding the angle E2 because we were not asked to find the angle E2. Right. Then we need to know our properties for quadrilaterals. So I'm going to do number 50. I think that will basically be the concluding question, and I'll do the rest tomorrow morning at 5:30. Okay, because I need to get going. ABCD is a rhombus. Okay, if you look at your rhombus, your vertex, angle A, angle D, angle C, angle B has your diagonals with the angles there, A1, angle A1, angle A2, angle D1, angle D2, angle C1, angle C2, and angle B1, and angle B2. We are told angle B2 is 42 degrees. Okay. What is the size of angle ACD? What is the size of angle ACD? ACD, guys. They want the size of angle ACD. Okay. So if we look at that rhombus, the properties of the rhombus should ring in our heads. Okay. We know that a rhombus, the diagonals of a rhombus, they bisect at 90 degrees. Okay. The diagonals of a rhombus, they bisect at 90 degrees. And then obviously, the opposite sides of our rhombus will also be what? They'll be parallel. And we also know that the diagonals bisect the corner angles. Okay? The diagonals also bisect the corner angles. So C1 would be equal to C2 if those angles are known. C1 would be equal to what? C2. That's very key, guys. You know. So if we know these things, then it makes life very easy. Very, very beautiful. Okay. Now, I'm sure you guys can look at this particular rhombus and you can see that angle B2 is in actual fact equal to angle D2. Why can we say angle B2 is equal to angle D2? It's because obviously all four sides of a rhombus are equal. So if angle B2 is 42 degrees, then angle D2 should also be what? 42 degrees. Okay, for reasons that are obvious. Okay, for reasons that are obvious. Okay, I hope that makes sense. And then of course we could use the whole concept of triangles. For triangle DBC, right? DBC, we get angle C, we add B2, we add D2, and then we add the entire angle of C, all right? And then we get angle DCB, okay? 180 minus 84, we get the entire angle of DCB. Then we divide that angle by 2 to get angle CACD, okay? Because ACD is C2, we get that specific angle, and then that basically concludes that. Or maybe you can use an alternative approach, okay? Maybe using the idea of alternate angles, right? Use the idea of alternate angles. For instance, angle B2 and angle angle B2 will be equal to angle D1. Okay, alternate angles, because AD is parallel to BC. Remember, rhombus has opposite sides being parallel as well. That's they're not there in the diagram, but you can always utilize that, you know. So some people maybe may use that approach to basically getting to the answer. Okay, so it really depends who is doing the question. So as I said, personally, angle D2 is equal to angle B2. Why? Okay, so first and foremost, we know that BC will be equal to what? DC. Okay, why? Adjacent sides of a rhombus. Let's start right there. Okay, or we can say sides of a rhombus. So BC is equal to DC, that's what we know. Therefore, we can say angle D2 is equal to angle B2, which is equal to what? 42 degrees. What's the reason? Angles opposite equal sides. That's why. Okay. Then I can update my diagram, because now that means D2 is 42 degrees. Okay. Very important there. Okay. D2 is equal to B2. The reason is, which is equal to 42 degrees, and my reason is angles opposite equal sides. Okay. Then I can actually now say in triangle DBC, B2 plus D2 plus the entire angle BCD will be equal to 180 degrees. What is that reason? Interior angles of triangle. Yeah, you can use sum of angles in a triangle, or you can say angle sum in triangle, one of three of those reasons. Angle B2, 42 plus 42 plus angle BCD, which is 180 degrees, so angle BCD is 180 degrees minus that 42 plus 42 gives us 84. Okay. No, that doesn't really matter. I was taught to name triangles from the smallest letter. Okay. It doesn't really matter. As long as the middle letter is basically the what? It is the indication of the angle you are referring to. That's what's important. And then if they have the numericals for the angle named, then you just write the angle as angle P2 or D2 or D1 as per the naming of the numerical angle. So 180 minus 84, I'm sure you guys know that is 96 degrees. BCD. Okay. 96. So the truth then is C1 is equal to C2. Why? Diagonals of a rhombus. We know the diagonals of a rhombus, they bisect each other at 90. But interestingly, in us, angle C1 plus angle C2 is equal to angle BCD. Okay, and angle, since C1 is equal to C2, we are interested in finding who? C2. All right, so we are going to say C2 plus C2, because remember C1 is equal to C2, so I can substitute in the place of C1 C2. C2 plus C2 is equal to 80, 96 degrees. And I'm going to have 2C2 is equal to 96 degrees. I divide both sides by 2. So that means angle C2 is equal to what? 48 degrees. See? And therefore I conclude that ACD, because remember ACD is actually angle C2, which is 48 degrees. Makes sense? Yeah, so now I can actually go and choose my option. What is the size of angle ACD? It is C. I choose my option having done the calculation, so it makes sense. Okay, but guys, please, paper 2, let us make sure that when we write something, especially if it is new, let us indicate the reason. You say BC is equal to CD. Why? Because sides of a rhombus. We can say adjacent sides of a rhombus. We know that the adjacent sides of a rhombus are equal. Meniere then went on to say angle D2 is equal to angle B2. Why? Which is equal to 42 degrees. The reason is, I indicated that BC is equal to DC. Those are, like, it gives me that isosceles triangle. So I know angles are opposite equal what? Sides. That's my reason. Then I go to triangle DBC. And there I add my angles, all of them. Angle P2 plus angle D2 plus angle BCD. BCD. This is grade 9, but applicable to grade 10, 11, and 12 because they do such, and grade 8. Angle P2 plus angle D2 plus angle BCD. BCD is equal to 180 degrees, interior angle of a triangle. I then add the angles together. 42 plus 42, which is P2 and D2, right? Plus the angle PCD equal to 180. I then solve. 42 plus 42 is 84. I transpose it, it becomes negative 84. 180 minus 84 gives me 96. So that's angle PCD. But what do I know about angle PCD? I know that there C1 is equal to C2 for that particular entire angle. C1 is equal to C2. Why? Those are the diagonals of a rhombus. The diagonals of a rhombus, they bisect the corner angles. But I can write that. Then C1 plus C2 gives me this angle PCD, which is 96. But remember, since I said C1 is equal to C2, in the place of C1, I can write in its place, substitute C2. C2 plus C2 is 2 times C2, which is equal to 96. I then divide both sides by the coefficient of C2, which is 2, and I get angle C2 is 48 degrees. Remember, angle C2 is actually angle ACD. That's just another way of referring to angle C2 as ACD. It is C2, which is 48 degrees. So my option or my answer is C. Unfortunately, I have to end right there because of time and time constraints. See you tomorrow, guys. 5:30. 5:30. Thank you so much to those that were able to gift. The gifts that I appreciated: roses, ice creams, and anything basically that is gifted is actually really appreciated when it does come. So thank you so much. Sasa is saying the answer for 51 is A. Okay, I guess we will tune in next time. I'm going to hold that to your credit, Mr. Sasa. As you say, A is 56. A is 56 degrees, but we will actually do it tomorrow. Thank you so much, guys. As I said, these videos that I'm doing, this live lesson, I'm going to save it, upload it on my YouTube channel. Please go to the link in my bio if you want to get access to my YouTube channel. Copy the link of the YouTube channel, go and paste it in your search engine, Google search engine, and then press search. It will send you to the YouTube channel because it seems like people are having problems clicking on the link and it's sending them to the YouTube channel. Secondly, also go to my WhatsApp channel. There's this first link is the WhatsApp channel, second link is the YouTube channel. Copy the WhatsApp channel link, paste it on the Google search engine, press search, and then it will send you, the WhatsApp link will send you to my WhatsApp channel. Be part of that too, so that when I when I place the clickable links in the WhatsApp channel, you can get access to the videos and you can watch them at your own time. This may have been too fast, you may have missed certain things, but if you go then to my playlist on my YouTube channel, the grade 9 GEC Maths playlist, you will find the 7 other videos that I've done of the questions from question 1 all the way to 40 something. Today I've gone up to 50, so I'm going to upload this video to add to that series of those videos. You can watch them at your own time, at your own pace, and digest the content, so that if you have things that you have questions about, you can always ask me, send me a message, or you can await for when I go live again. Thank you so much. Lots of love. Have a great day. Thank you for joining. We really appreciate it.